Good morning, welcome to Morning Maths, day 35 now. And you just need your pencil and paper, or pen and paper. Let's get started. Year 3 level questions. Everything's mixed up today, just like this mixed fruit. In fact, I'm probably just going to keep it all mixed up from now on, apart from in year 3. But question 1, year 3, how many tens is 900? How many tens is 900? Well, 900 is 900 units, 900 units. It is 90 tens, that's our answer, 90 tens. It would also be 900s, 900s. So how many tens is 900? It is 90 tens, like this, 90 tens. Because 90 times 10 is 900. And we're on question 2. 432 added to 87. Added to, that means plus, doesn't it? Add or plus, added to. 432 added to 87. So be careful with your lining up. It must line up down the right, which is this side here. It must line up straight down there. 432 plus added to 87. Pause if you need to copy. 2, let's put hats on this time, units, tens, hundreds. 2 plus 7 is 9. 3 tens plus 8 tens is 11 tens. 1 and carried a 1. And 4 hundreds plus 100 is 5 hundreds. 2 plus 7, 9. 3 plus 8, 11. 4 plus 1, 5. And we get 519 because plus makes things bigger. That's why this. 432 got bigger, became 519. Okay, and let's move on to question 3. We have a takeaway here, takeaway, takeaway. That means minus 565, take away for 342, 49. Have I done that right? 565, take away 349. There we go. So, 5 take away 9 we can't do. We need to do some borrowing or taking, whichever you call it. 6 goes down to a 5, and we can borrow a 1. So we did 6 go down to a 5. We've got 15 take away 9, which we can do. 15 take away 9 is 6. 5 take away 4 is 1. 5 take away 3 is 2. 216, because minus usually makes things smaller. 565 take away 349 is 216. And we go on to question 4. Question 4, I'm going to do this very similar to how I did this yesterday when I do 35 times 4. 35 times 4. This is quite a difficult question in year 3, so it can be split up. The 4 is just one digit, isn't it, over this side, so that's fine. But 35 could be split up into its units and its tens. It's 5 units and it's 3 tens. 3 tens is 3t, 30. 3t, 30. So, let's do the 5 times 4 bit. I might write, it doesn't have to be lined up or anything, but let's do the 5 times 4 bit. So I've done 5, I've written 5 times 4. Now we've still got to do 3t, 3 tens times 4. 3 tens, let's do that purple. 3 tens is 30, isn't it? So we've got to do 30 times 4. There's 2 parts to this question, really. If you're going to do 35 times 4, this red part is where you do the 5 times 4. And this purple part is where you do the 30 times 4. Because this 3 is not really worth 3, it's worth 30, isn't it? Because it's in the tens column. Okay, so if we do 5 times 4 and we do 30 times 4, we can add the answers up at the end and we'll have an answer. Let's move that over here. So 5 times 4, we can use our songs for 5 times 4. 5, 10, 15, 20, that's 20. 30 times 4, well this is just 3 times 4 in disguise. So I'm going to do 3 times 4. 3, 6, 9, 12, it's 12, but it's not 12 because it's really 30 times 4. So you have to place this 0, 1, 2, 0. 12 with a 0 placed, is actually 120. So I did 5 times 4, which was this red number here, and that was 20. I did 30 times 4, because that 3 was worth 30. You know that from your place value. And 30 times 4 was 120. I have 2 answers. I need to put them together at the end. I'm sneakily just going to put a little plus in here and add them up here. Oh, something's going to go very wrong though if I do that, because they're not lined up correctly. They'd have to be lined up correctly for me to add them. So now they're lined up correctly, I can add them. 0, 2 plus 2 is 4, and 1. 20 plus 120 is 140. And our answer is then 140. 35 times 4 is 140. Okay, that's one way of doing question 4. I'm going to do it in another way now. Another way of setting this up. There's lots of different ways of doing something. But basically what we're doing each time is we're splitting this 2-digit number up into 5 and 30, 30 and 5, and multiplying them both by 4. This is another way of doing what I just did. Copy this or just watch it, whichever you want. I'm doing question 4 again, basically, in something called the grid method, which I know some of you will know. Year 4 certainly do know. The grid method is where you still split up this 30 and 5, just like I did a minute ago, but you split it up like this, 30 and 5. Because the question is 35 times 4, so I split it up into 30 and 5 times 4. And then what you do is you do 30 times 4, and you put the answer in this box here. And then you do 5 times 4, and you put the answer in this box here, where they meet up. And you have 2 answers which you add up at the end. This is all very similar to what I just did. It's just set out in a different way. I'm still doing 30 times 4 and 5 times 4 to do 35 times 4. So, let's do 30 times 4. 3 times 4 is 12. And you place that 0 from the question. And over here, 4 times 5 is 20. See, I've got 2 answers, 120 and 20. I added them up a minute ago, didn't I? And it was 140. Just check again that it's 140 still. Nothing's changed in maths. 140. So I know that 35 times 4, which was our question, is 140. So this method here, this is called the grid method that year 4 use a lot. Year 4 use 2 different methods, but in year 3 we are going to be using this grid method. So from now on each day I'm going to use the grid method, among other things, to get the answers to these more difficult multiplications, because we can't just do our times tables for 35 times 4, because we don't know our 35 times table song. We know our 4 times table song, but we don't know it up to 35s. So when it's questions like this, you need a bigger method, and the grid method is what we call this, because the grid is this black bit here. Apologies to year 4s listening to this, because I know you'll know all this, but year 3s, I've not talked about the grid method with them before, so I wanted to spend a bit of time on it. I'm going to move on now to question 5. 28 divided by 4. 28 divided by 4. This is the same as saying 28 shared between 4. And very importantly, it's the same as saying how many 4s in 28. You can sing to the answer. How many 4s in 28? Count on your fingers. 4, 8, 12, 16, 20, 24 and 28. 7 fingers means it's 7. 28 divided by 4 is 7. I'm going to draw a picture of this. When I start my times table song, we don't really say 0, but we kind of starting on 0 because the first number we say is 4. Remember what I sang? 4, 8, 12, 16, 20, 24 and 28. I stop at 28 because that's the number we're dealing with, 28. So you basically count up in 4s from 0, from the beginning, from silence. You just go 4, 8, 12, 16, 20, 24 and 28. So you see how many 4s fit into 7. 1 lot of 4, 2 jumps, 2 lots of 4s, 3 jumps, 3 lots of 4, 4 jumps, 4 lots of 4, 5 jumps, 5 lots of 4, 6 jumps, 6 lots of 4, and 7 jumps, 7 lots of 4. We know the answer was 7. 7 jumps. I'm going to just count the jumps just to check. 1, 2, 3, 4, 5, 6, 7, just to check the answer was 7. So this here in green, this is a picture really of what you sing, isn't it? When you do how many 4s in 28, this is a picture of what you sing. The red numbers are your fingers, the black numbers are what you say. You don't say 0, but you say 4, 8, 12, 16, 20, 24 and 28, and your fingers are counting the red bits. And when you finish counting, your fingers tell you the answer, which is 7. So there's basically 2 ways of doing division. One, just singing, and 2 is basically a picture of the singing, using a number line to do division. There's more ways, which I'll show you in future days. Let's go on to the year 4 level questions, question 6 next. 4,000 plus something equals 4,896. We've done a lot of these now, haven't we? 4,000 plus a mystery is 4,896. Well, the 4,000 is already in the answer, but the 896 that's in the answer, none of that is there. So it's the 896 that has to be added. Always check these when you've written in the box. 4,000 plus 896, 4,896 equals 4,896. That makes sense. So 896 was what went in the box, which was our mystery, our missing box, which was our answer in this case, really. And we're on number 7. Decrease. Do you remember what that means? Decrease, go down. Go down. Take something away to go down. Decrease means take away. Subtraction. Minus. That's what it means. 2,500. Take away 1,777. Sounds like a date, 1777. I don't think I know anything that happened in that year, although I'm sure lots of things did. 2,500. Take away 1,777. We'll do the taking or borrowing. Is that right? Yes, I borrow 1 from there, and it goes here. That goes down to a 9, and that goes here. 10 take away 7, 3. 9 take away 7, 2. 4 take away 7. Oh, we can't do that still. So let's borrow in a different colour this time. 2 goes down to a 1, or the 2,000s, because it's a 1,000 column, goes down to a 1. 1 comes over here. 14 take away 7 is 7, and 1 take away 1 is 0, which you don't have to write. So 723. The top number got smaller when we took something away. Because that's what takeaway does, make things smaller. And we are on question 8. 40 lots of 40. 40 times 40. I'm going to do this one with times tables in disguise. You could do it with grid, you could do it with standard method, but there's no real need. This one's quite easy, really. 4 times 4 in disguise. 4 times 4 is 16. How many zeros in the question? 1 there and 1 there, which makes a total of 2. 1, 2. And we're done. 40 times 40 equals 1,600. It's like 4 times 4 in disguise, but 2 zeros from the question had to go as 2 zeros in the answer. The 2 different zeros in the answer. 40 times 40 is 1,600. Lots of, I didn't even mention, of course, but lots of does mean times, doesn't it? That's why I did times. Lots of. 40 lots of 40 means you've got 40 times 40. You've got 40 and you've got it 40 times. Let's go on to question 9. Divide, also known as share, isn't it? Divide 1,000 by 4. And hopefully you know this is the same as saying how many 4s fit into 1,000? A lot. There's a lot of 4s in 1,000, isn't there? How many times can you get 4 out of 1,000? Well, how many 4s in 1? 0 carried a 1. How many 4s in 10? 4, 8. I counted up to 8, which was 2 fingers. But I only counted up to 8, and that says 10. So I counted 1, 9, 10. Remainder 2. How many 4s in 20? 4, 8, 12, 16, 20. 5 fingers. 5. How many 4s in 0? It's just 0, but it's a very important 0. Because it changes what does say 25 into 250. A big difference. This 0 at the front is not needed, is not important. It's not worth anything. Weirdly, because this 0 at the end is worth a lot, it's very important. It's not really worth anything, but it's very important because it makes the answer 250. And if you didn't put it, you would be saying 25, which would be wrong. So 250 is the answer. Divide 1,000 by 4 and you get 250. Let's go on to question 10. Oh, I should have moved this down by now, shouldn't I? Sorry about that, fast people who are waiting while I just left that sitting there. Number 10, total of. That's normally going to mean plus. Total of 5,973. And means plus as well. You've actually got two words. Sorry, of doesn't mean plus in maths. Unless it's with something that means plus, like total. Total means plus, and means plus. I won't even mention of today. So total of 5,973 and 798. You've got two words that mean plus there. Total and. Add them up in purple for no reason at all. And we'll see what we get. Seem to be getting 6,771. That's because plus makes things bigger. And this, when we got to the answer, got bigger and became this. Only got 1,000 or so bigger, didn't it? Because we didn't add more than 1,000. That's question 10, and we're on the Year 5 level work, question 11. How many hundreds in 50,000? Lots. Lots is definitely true. Lots. How many hundreds in 50,000? Well, 50,000 is 50,000 units. And it's 5,000 tens. And it is 500 hundreds. And that's our answer here, isn't it? How many hundreds in 50,000? The answer is there's 500 hundreds in there. 500 hundreds. Hopefully you're getting a bit used to these questions now. We've been doing those for the last week or so. So question 11 is 500 hundreds. There's your answer. And we're on question 12. 7.7 more than 7. 7.7 more than 7. More than means plus in maths. More normally means plus. Unless it's how many more or how much more. When it's minus, it's a trick question. 7.7 more than 7. Okay, more than 7. We'll add that on to 7. But 7 needs to be 7.0 to line up the point correctly. I'm sure you're okay with this in Year 5 now. If you're not, just keep practicing. 14.7. 7.7 more than 7 is 14.7. That's right, because 7 and 7 is 14, and then you have the 0.7 on the end. 14.7. Question 13, decrease. Year 4 had this word today, decrease. It means take away, it means minus, it means subtraction. Decrease 100,000 by, oh my gosh, this is crazy. This is absolutely crazy lining up here. I'm going to go right, I'm going to have to go right over here, I think, to fit this in. Decrease 100,000, which doesn't have any decimals on it, because a comma is not a decimal point. Doesn't have any decimals on, and we've got to decrease it by 0.89, which does have a decimal. So I'm going to put a decimal on 100,000. If there's no decimal point in a number, where does it go? At the end. 3 very important words there. What goes on the end of 100,000? If it doesn't have a decimal, I don't think I said that right. What I should say is, where does a decimal point go if there isn't one? At the end. Line up the point underneath. This is really crazy lining up. You don't see this very often, do you? Trying to trick you. The people who did it on their own may well have got tricked. Let's place these zeros here, because 100,000 is the same as 100,000 point nothing, or 100,000 point nothing nothing. Still the same. And now we can actually do it. It's going to be more boring than I've done in any of the morning maths. Really strange lining up. Let's go. 0 take away 9 we can't do. Can't borrow from there, 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 can't borrow from there. Oh, we can borrow from there. 0 goes there, and we lend a 1. And we have to do all this. All the way across. All these 9s. Some people quite like doing this, don't they? Don't cross out the last one, it stays as a 10. 10 take away 9 is 1. 9 take away 8 is 1. Line up the point. And then we've got all these 9s. It's just 9 plus nothing, 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 and that was 0 at the front, which we don't need. So our answer is 99,999.11, which is very nearly the 100,000 we started with, because we only took off a very small amount. If you do put a comma in, commas go, I normally say 3 from the end. Well, they go 3 from the end of whole numbers, which is where the decimal point is. So if there was a comma, it would go here. But you very rarely see commas and decimal points in the same number. It's just not something you see much. But if you did put a comma in, it would have to go here. 99,999.11. That's how you say it, not 0.11. I've got a feeling I said that earlier. It's 99,999.11. That's how officially you say it. Now, that was a strange question. And we're on number 14. Multiply 7 by 4.68. Well, multiply is obviously times, multiplication. I'll do this one quite fast. You don't line it up correctly because that's what multiplication is like. You basically don't line up the decimal point, which if there was one on a 7 would go there, wouldn't it? So it's not lined up correctly with the decimal point, but it's just how multiplication goes. 7 times 8, 56. 7 times 6, 42, plus 5, 47. 7 times 4, 28, plus 4, 32. That's not the answer, no, though, because there's 2 decimal places in the question, so you need 2 in the answer. So it will have to be 32.76. Some people are very bad at remembering these decimal points. You do all the work, leave that little point out, and you get the question wrong. So you really got to try to remember those decimal points. 32.76. Question 15. How many 30s in 13,740? How many 30s in there? Well, how many somethings in a something? How many somethings in a something is division? That's division. So we're going to divide it by 30. Find out how many 30s are in it. That's how you do it. You might need your 30 times table. Good news, that's very easy to do. It's your 3's with a 0 on the end. I'm sure you know that. If you need your 30s, just do your 3's with a 0 on the end. You never need more than 9. 9 times 3 is 27, so 9 times 30 will be 270. Place a 0 each time, and we've created our 30 times table, which makes this quite easy to do with the bus stop because we have the times table written down there in the luminous green. How many 30s in 1? Definitely 0. Carried a 1. How many 30s fit into 13? 0, because 30 is still too big to fit into 13. Carry the 1 and the 3, and we have 137, because you carried 13, 13 and the 7, 137. 13 in front of the 7, 137. So I'm going to count in 30s, but I can't go past 137. 1, 2, 3, 4. That's too many. 1, 2, 3, 4 is 120. I got 4. 4 goes up the top. We counted up to 120, but we were trying to count up to 137. So it's quite a big remainder. It's the difference between 137 and 120 that we counted to. The difference between means takeaway in maths, an easy takeaway, but 17 gets your next remainder, big old remainder again. 174. How many 30s in 174? 174. 1, 2, 3, 4, 5. It's 5. Okay. We only counted up to 150 though, and that says 174. So the difference between 174 and 150, what's that? An easy takeaway, but it is 24. 24. 240. Now, if this works, we've done it right. Very likely to have done it right. How many 30s in 240? 1, 2, 3, 4, 5, 6, 7, 8. It's exactly 240. It was 8. We got to exactly 240, which means no remainders. And in the SAT's arithmetic test, there isn't any remainders on these long division questions here. So that's that. 458 is our answer. Big question. Now we're on 16, year 6 level. 75 divided by 1,000. 75, I'm going to divide it by 1,000, which means I'm going to use a moving method, because on dividing by 10 or 100 or 1,000, you can use a nice, easy little method. But you've got to be careful. Right, put a decimal point on the end. If there's no decimal point on a number, where does it go? At the end. Line up one underneath. Division makes things smaller. Small things are over here, so we're going to move it that way. Okay. 3 zeros. 1, 2, 3, which means 3 places smaller. So the 7, instead of going in the same place, instead of going in the tens column like it is at the moment, it's going to get 3 places smaller. 1, 2, 3. It's going to go right over there. Let's see if I can move this without dragging everything about. I don't even really need to write divided by 1,000. I know I'm dividing by 1,000. So 3 places smaller. I just want to put the hats on, basically. That's why I moved it. Tenths is over here after the decimal point. hundredths. The decimal point is not a place, by the way. See how it's written on the line? It's not written in a box. It's written on the line because it's not a place. It just goes in between two places, the units and the tenths. So you have tens, units, tenths, hundredths, and thousandths. The 7 moved 3 places smaller. 7 being in the tens, instead of being in the tens, it went 1, 2, 3. It's in the hundredths, much smaller. The 5, instead of being in the units, it goes 1, 2, 3, right over there. We've got a point hanging around in the air, and we've got 7, 5. Well, what we have to do, what do you think we have to place there? There's a special digit that can be placed there, and needs to be placed there, and it's a place holding 0. The answer is 0.075, otherwise known as 0.075. So with the moving method, we moved it 3 places smaller, and we get 0.075. This is one that is quite difficult to do in your head, because there's no zeros to just take off or anything like that, and it's quite a complicated decimal. Anyway, question 17. I feel like this is a long video today. Some big questions. If you've been with us since the first day, I'm sure you're noticing that the level is gradually increasing. Questions are gradually getting longer. What have we got here? Increase, well, that means plus. 99,455 plus just little old 97 over here. No decimals involved, so we line up down the right, and we're doing plus. Make sure you do the right sign. I'm talking to myself when I say that, because I know what I'm like. Is that right? 99,552. It was 455, now it's 552. Yeah, that looks right. If you do a comma, it goes 3 from the end of the whole number. We only have a whole number. 99,552. Question 18. Take something away from something. Take 0. That looks like a backward 6. 0. Make sure zeros look like 0. Lots of people lose marks and their zeros look like 6s and their 9s look like 4s. Make sure digits look right. Take 0.569 away from 10. I'm going to have to put 10 up here. I'm going to have to make it 10.000 to line up properly here. Is that right? Take 0.569 away from 10. 10 point nothing is 10. Okay. Line up the point. Lots of borrowing or taking to do. All the way along. Because 0 take away 9 we can't do, can we? All the way along to there. I do this quite fast in year 6. You can always pause if you need to catch up. 10 take away 9, 1. 9 take away 6, 3. 9 take away 5, 4. 9, important 9. And nothing there. 9.431. So 10 take away nothing and a bit. So 10 take away a bit was 9 and a bit. That makes sense. If you know your number bonds to 1,000, there's a number bonds to 1,000 check, which confirms to me that it is right. And we go on to question 19. Very similar to yesterday where we found a fifth. Today we've got to find a sixth. How do you find a sixth of something? You divide it by 6. When it's a big number like that, you're going to use the bus stop to do that, I'm sure. Find a sixth of 52,470. We'll divide it by 6. In orange, I don't use that much. Wonder if you can see it. Yeah, that's okay. Doesn't like the orange pen. How many 6s in 5? 0 carried a 5. How many 6s in 52? 6 and 12, 18 and 24. Then 30, 36 and 42. 48 is 8. From 48 up to 52, there's another 4. 49, 50, 51, 52. 4. How many 6s in 44? 6 and 12, 18 and 24. Then 30, 36 and 42. That is 7. But I only counted to 42, and that says 44. It's 43, 44. The remainder 2. How many 6s in 27? 6 and 12, 18 and 24 is 4. I only sang to 24, that says 27. So 25, 26, 27. I count in ones to find a remainder 3, and this is going to work nicely now. How many 6s in 30? 6 and 12, 18 and 24. Then 30, it's 5. My finger said 5. I'm counting all that on my fingers. I actually like to do that these days, since we invented these songs. 8,745 is the answer. And we're finally on question 20. This has been the hardest day, I'd say. Or maybe not the hardest day, but definitely the day that involved the longest methods. And we've got another long method now. Long multiplication for 75 times 75. This is almost the only question of the day that didn't have words in it. Well, there is a few, but we've got a lot of vocabulary on the screen now. I wonder if you know all that vocabulary. I wonder if you know what every single one of those words means in maths. 75 times 75. Place this 0 here. I'm going to do in purple, 5 times 75. 5 times 5, 25. 5 times 7, 35. Plus 2, 37. So thank you for that. Did that purple one. Might as well cross out this while I'm here. I'll just check though. 5 times 5 is 25. 5 times 7, 35. Plus 2, 37. That looks okay. Do the next bit in red. Replace the 0. Don't forget that. 7 times 5 is 35. And then 7 times 7 is 49. Plus 3 is 52. I'll just check that while I'm here. I've done the red bit. But 7 times 5 was 35. It's really 70 times 5, but we placed a 0. So 7 times 5, 35. 7 times 7, 49 plus 3, 52. Looks okay. I'll add them up in black. 5 plus 0 is 5. 7 plus 5 is 12. 3 plus 2 plus 1 is 6. And 5 at the front. 5,625. 75 times 75 looks like it might be a more famous or more round number. It looked like it to me, but it's not. It's 5,625. So thanks for listening. Let's have a look at the answers. We got that last one right, didn't we? Oh, something's changed a bit here. Just noticing. Sorry, flicking through. I noticed that I just popped a comma on that question there when I did the second page. Now they should be the same. Sorry about that. Anyway, there's your answers. Sorry to flick around so you couldn't see them. Let's check you get everything right. Pause if you need to. And I'll see you again next time.